Dear students, following question is my personal favorite question from this particular test series from topic of connections from subject of steel structure. Here a diagram is given where a moment carrying connection, this is called as bracket connection, and to be precise this is called as bracket type 2 connection is given where 10 bolts are being used to transfer a load of 100 kilonewton which is acting at eccentricity of 200 mm to a column, and we have to find that what and we have to find the resultant force that is acting on bolt 2. One is clearly shown, 2 is marked. Now if we talk about various forces that will be acting on this force 2, one will be since bolt will be giving response to this force of 100 kilonewton, so reaction will be in this direction, and one, now since this is acting at eccentricity, some movement will be generated here, and to balance this moment of amount P into E, one tangential force, I'll say that force that is acting normal to the radial line will be acting like this, and it will be perpendicular to the radial axis. For example, if I talk about this bolt, it will be acting like this, that if this is the line joining center and bolt, one tangential force will be acting on this, say nth bolt like this, and one direct shear will be acting like this. Similarly on this bolt, it will be like this, one radial line and perpendicular force just to counterbalance. Say if this is acting in clockwise direction, this force should produce equal, means summation should be equal and opposite to this P into E. That's why directions are very important if we are talking about resultant force that is acting on the bolt. So if we talk about action on the bolt or reaction of the bolt, they are one and the same thing. Magnitude will be same. The only difference will be in direction of action of that action and reaction. Now we know that direct shear will be equally shared by all the bolts, that is 100 kilonewton force will be divided amongst 10 bolts giving 10 kilonewton as direct shear. But if we talk about tangential shear, it is given by M into R upon summation Ri square. It is a very standard and very easy to derive. Just take moments about each bolt and equate that to P into E, individual moments about each bolt, and this bolt will be most highly stressed, one, this one will also be highly stressed, this will be highly stressed. So all bolts will not be having equal magnitude of this force because of eccentricity. That's why it is P into E into R, that is farther the bolt from the center, more tangential force will be acting on it. Now P is given as 100, E is given as 200. Now if you talk about bolt number 2, R will be 60 square plus 80 square, which I have written as 60 square plus 80 square, it's under root, and in denominator summation of R square, that is distance of each bolt from the center. Its summation is taken of 4 bolts, this bolt, this bolt, this bolt and this bolt. They are located farthermost at the distance of 160 square plus 60 square. Distance of this bolt will be under root of 160 square, because 80 plus 80, it is located at 2 pitches away from the center, and here it is 60 because we are taking distances from center point. So it will be under root of 160 square plus 60 square, but we have to take R square, so it is 160 square plus 60 square taken for 4 bolts, 1 2 3 4. If you talk about this bolt, that is in the line of 2, and similarly if you talk, say this is 2 dash, it will be having distance of 80 square plus 60 square, it's under root, and there are 2, this bolt and 2 dash, so 4 here, and 2 bolts which are located in line of the center point, they will be at distance of 60 and its square, that is 60 square, that is 2 times the 60 square, P tangential comes out as 129 Newton, and if you talk about P resultant, it is PT square plus PR square plus 2 PT PR cos theta, where cos theta is angle of action between tangential force and direct shear force, and this will be obviously equal to this theta, because this angle is 90, this angle will be 90 minus theta. This complete angle on opposite side has to be 180, making this theta, that is angle of, if I draw this on some clear scale like this, I'm saying that this is angle theta, this angle is 90, this angle is 90 minus theta, so this angle automatically reduces to theta, that is angle of action of forces is same as angle of inclination of this radial line of bolt 2 with horizontal, which comes out as B by H, that is 60 upon R, which is 80 square plus 60 square. So P resultant comes out as 19.87 kilonewton, making B as the closest choice. Thank you.